Good morning. We'll begin the file attribute program, whatever that we were discussing about that. See, please look into that in our syllabus. We have some of the programming exercise. 4 can be 4. We have started and we'll be continuing that one in the afternoon today. I mean, today morning in the second class, that is at 11:30. Directory listing we are seeing, and file attribute, displaying the file attributes we are already started doing it, and let me complete this and get into. So with this, all these three, these two information available with you, you will be in a position to do the implementation of ls-l command. So implement all these programs, right? Be ready, because I1 we are focusing on programming and some theoretical part. And please remember, for IA1 we have got a 3 question. Question number 1 or 2, and third question is mandatory. You can refer the Google class for IA1, IA2, IA3 sample question available. And also in Google class we are given a question bank for the first 3 unit. Okay, prepare on that line. That will help you to prepare better for the semester end exam also. Semester end exam is common for both lateral entry and regular student. Please look into that. Okay. Dhoni, is it okay? The instructions? Dhoni, is the instruction okay?
Yes, sir.
Okay. Quickly acknowledge so that we can proceed. Okay. Now let's look into the Unix programming, the whatever that okay we have stopped yesterday about the file attributes. Right? Look into that. Yesterday I was talking to you about the start.h header file, right? Then time.h, types.h. We will see that detail as and when we come across this, right? Now consider I have declared one variable here, right, with the complete path name of that file, and the name of the file is 0test.c, right? 0test.c, when you look at that, right, cat 0test.c, this is available. This is a small program that has been written, and when you look at its attribute, right, see here, it is a regular file, and it is a read write execute for the owner, read write execute for the group, read write for the group, read write for the others. It has got 3 links. Okay, the user, okay, this one, and group name is sdmcd, 216 bytes, and timestamp is this, and name of the file is this. Is it clear, right? Is that clear to you?
Yes, sir.
Right, that's good. Now let's look into that. How do we write a program to get into? Right, I told you there is a structure called StartH. Right, this StartH contain, okay, all the information attributes of the file. How to retrieve it? Right, we use a function called lstat. This lstat, we have to give a path name which contains the path of a file, including the file name, whose attributes you want to retrieve, and you have to pass the address of the structure which you are using it here, stat. Okay, and if it is equal to -1 return value, then it is an error. Use a p error system call to display the system error, and this is a label indicating that at this point you can give any label, but system will log its error message and then continue, right? Then yesterday we are seeing that one, right, how to display the size of the file, right? Size equal to, right, the structure whatever you are using dot st size, right? Now we will see the other part of the program. Until this, okay, it was okay, and we did it yesterday. Let me try this, run this program. Right, look at that file. Attribute of a file is 0test.c, and size of the file is 216 bytes, and 216 bytes, when you look at this ls-l 0test.c, you'll find that the size of file is 216 bytes. This is where we are stopped in the last class. Is it okay? Is it okay?
Yes, sir.
Right. Okay. Now
Yes, sir.
let's look at the remaining part. Everyone, okay, we are getting through the crash course like that. Everyone should do the programming on that day, and discuss with me in the next day if at all you have any issues, right? Everyone should do it in Unix environment. This today one more new person has joined, Badami. Badami, are you in here in the class?
Yes, sir.
Badami, I've told him to join, right? His number is there. Okay, Dhoni, you can call him later and ask him to be in sync with the regular classes. Okay, now let's look into the different privileges, whatever that the different people have on the file, right? Security, right? What are the things that you have? Read, write, execute permissions, right? So, what kind of security it provides the Unix on operating with the file? So, the owner, group, and others, right? They can have a read, write, execute permission, right? You can set this, you can reset this, you can manipulate all these things. But let's look into, right? How do we display all these things? Right? So that information is available in st underscore mode field of the struct stat. Let's look at the struct stat. St underscore mode. Right, it is here. St underscore mode. Right? So now you need to, it contains a read write execute permission on, okay, for the owner, group, and others. So we need to, okay, extract this information from that. How do we do? Right? See here, you take st underscore mode, do the right and with binary, okay, and it is not a logical and with some of the mode constant defined by the system, right? And when you and with this, whatever that is available, bits have been set in this, okay, that you get it, and that you are displaying it. Are you getting it? So now, when you look at the file permission is 766. What is the meaning of that? Let me explain to you about that. Let me explain to you. For that, I will set this. Okay, now see here. Okay, the value 766. How it is coded? This is for the owner. This is for the group. This is for the others. Okay, please understand this. Right? This is an octal number. Is it clear? Right? And
Yes, sir.
each one, right? Look at that. This is for write, read, write, and execute. Similarly, for this also the bits are set for read, write, execute. For this also it is a read, write, and execute. So when you write 7 here, right? Okay, this, okay, these bits have a weight, okay, binary, right? Uh, now, okay, 2 raised to, this is 1, 2, 4. Similarly, here 4, 2, 1. Binary, you know about that. Binary number systems and all. 2 raised to 0, 2 raised to 1, 2 raised to 2, like this. So 7, when you code this one, it becomes 1, 1, okay, 1. 6, you code 1, 1, 0. Right? 6 again, 1, 1, 0. So this is the pattern, right? Okay, that's the mode bit is being set, right? How do we extract this? To extract this, right? Is it clear, all of you? All of you, is it clear?
Yes, sir.
Right? The binary number system already people have gone through. Please recollect this. Right? Now, let's get into this program. Right? So, whatever the bits have been set, you are doing and with, okay, read, write, execute for the owner, RWX, read and execute for the group, read and execute for the others, right? They're all 1, 1, 1, right? You do the and, right? And ensure that okay, this particular field, okay, when you do the AND, whatever the two things are there, that it will remain, right? So that you are going to display it, and that will be 766 here. Okay, it's a binary and you people know about that, right? Are you clear about that? Now let's little bit look into these aspects. File operations, a file mode, right? Now there are different mode in which a file can be opened, and file as a symbolic constant, right? Defined by POSIX standard, right? For example, look at that IRWXU, right? Right. So this is nothing but 00700. Okay, user has read, write, and execute permission. Right? Similarly, okay, look at that R USR. This is a constant, right? This bit pattern, when you look into that, right, the user has a read permission, right? So like this, a set of constants have been defined, right? These constants, okay, you can refer it, right, and try to get into and refer the standard library for this these constant. Got it? Are you clear about this?
Yes, sir.
Right. So in this program, now I will come to this program later. In this program, what we are doing is we are ANDing with that, so that the true representation of that we will get it, and then we display that one. So you will display, and then you will get the number 766 and octal number. Right? Is that clear? Hello?
Yes, sir.
Okay. Now look into that. We will get into the time, right? There is a library called ctime, which will convert one representation to user readable format. For example, look at the timestamp Saturday, July 22, 190144 2000 something, right? This is a user readable format, right? You have a system called ctime, which will convert the internal representation into user readable format. Is it okay? Hello, Dhoni, is it okay?
Yes, yes, sir.
Okay.
Yes, sir.
Now, there are three timestamps available: A time, M time, C time, right? But what are these things, right? Let's look into the structure. A time is a last access time. Whenever you access a file, right, it is going to modify this. M time, right, is a last data modification. Whenever you modify it, accessing the file is different, modifying that is different. Okay, C time, right, whenever at the last status change, right, right. So is it clear, right? So these times, right, we'll try to look into it, right? So we are displaying that the ST time, A time, ST underscore M time, ST underscore C time. What we do is we write, convert that into user readable format and okay, display it. But what is the internal representation? C time converts internal representation into right a human readable format. But what is internal representation? Let's have a look into that and spend some time on this. And in my program, I've given all the theoretical details also. Look at that. The C time will take that the field of the structure and convert that into, right? Convert that into human readable format I told you, right? Now, let's look into the C time, what it does, right? So there is something called a structure that's being used called struct time specification, STA time, right? STA time is a structure of the type time specification structure. Please okay, understand this. STA time, ST, right, M time, okay, ST, okay, C time, right? They are all a field of type struct time specification, which you already seen it here. Is it clear?
Yes, sir.
Okay. Now, what is this structure time okay, specification? We'll see. See that the structure time specification structure may be defined okay, as described in time.h. The time shall be given in terms of seconds since epoch. Did you come across the term epoch anywhere in your diploma while studying? Dhoni?
No, sir.
No, that's okay. We'll go through that. Now, epoch is what? It is a origin of a particular era. Right? Every product, it is a time operation, it will take one reference, starting point. From that, it measures the time lapsed in terms of seconds. Right? Are you getting it? Right?
Yes, yes, sir.
The epoch serve as a reference point from which time is measured. This is different for different product. Right? Time measurement units are counted from epoch so that the date and time event can be specified unambiguously. Right? Time okay, kept internally by computer system is usually expressed in number of time units that have lapsed. What is time unit? We'll see. For Unix, which follows the okay POSIX time, right? The epoch time is 0 hours, 0 minutes, 0 seconds of Thursday, 1st January 1970. So whenever you access the time, it will give number of seconds lapsed since this point, and this is called epoch. This is starting of era of Unix. Similarly, Microsoft Word, all that things, they have got their own things, right? Now let's look into that. This struct timestamp structure, right, has two fields. One is TVSec. It stores seconds, and TVNSec stores nanoseconds. Got it. So it takes this information, convert into human readable format, right? And that's being done by C time. It returns a pointer to the character. So C time converts the time pointed by a clock representing time in seconds since epoch to local time in the form of a string. Here's an example. Okay.
Excuse me, sir.
Mhm.
Sir, Manoj was asking to admit him to in the group class.
Oh, right. 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 Okay. Manoj, are you in? Manoj? Okay.
Yes, sir.
Okay, that's good. Okay, we have almost completed this file attributes related program. Okay, and now we'll go through this.
Okay, sir.
Right. Now look at that. Okay, I told you about the C time. Okay, are you getting this? Okay. Now look at that. C time. There are three fields I told you. A time, M time, C time. Last status change. C time is a function, is a built-in function system call that converts that the structure time expressions, epoch time internal representation into human readable format. Now let's look at this C time. Last status change. Look at that. I've given information here. C time originally meant creation time of the file. C time. However, it has since been used almost always to refer to inode change time. It is updated anytime the file metadata stored in the inode changes. So status change is inode metadata change. such as the file permission, file ownership, file creation, deletion of the hard link, whatever it is, right? That is the status, right? Here, see time is being referred that, right? Last status change. What do you mean by last status change? It is the creation, it is the file access changes, it is the ownership change, right? It is the privilege changes, whatever you do, that is called status. Last data modification is a content change, right? Last access for anything, read, write, execute, whatever that is there. This is time. Are you clear about this? Manoj?
Yes, sir.
Manoj?
Yes, sir. Clear, sir.
Okay. Manoj, what I'm telling is, you will be, okay, preparing the report and Himarashmi also will be preparing report. Everyone, in fact, right? So that all programs, whatever you have done, you have to prepare report, take a print copy with a proper cover sheet, index, page number properly, margin, everything aligned properly, submit it, right? So that
Yes.
that will refer as easy reference to you during placement preparation in 6 and all. Simply you can scan through. At the time, whatever you have done, you can easily recollect it. But if you have not done it, it is very difficult to this one. Got it?
Okay, sir.
In
Sure.
the last one of the interview, people asked name 20 system calls. Correct. Right?
Yes, sir.
You can use LSTAT, you can use CTime, right? You can use open directory, closed directory. There are many things. And during that one you can explore all these things. Now CTime, right? This CTime you can explain what it is and all. You can take examples and all. You can quickly collect it. Okay, when a report is available with you. For that reason, all assignments are important. Are you clear? And
Yes, sir. Sure.
and when you are writing a program, give enough theory. Whatever I'm giving it here, Manoj, tell Himarashmi also, and all people.
Yes, sir.
Right? So that it helps for the placement. And that booklet you will be submitting to me on the first day of your entry in the campus.
Okay, sir.
Okay? Okay, that's good. Right? Now, let's look at the difference between stat, LSTAT, and FSTAT. Stat, it takes a file name and returns. LSTAT also takes the file name, but what is the difference? And FSTAT is that it takes a file descriptor. The file descriptor meaning is that the file should be opened, then you get a file descriptor. So if you want to see the attributes of the file which is opened in your program, you have to use fstat, same. But file is not opened, but it is there in your file system, and you are passing it as a parameter and you are looking into, then you are using stat or lstat. But what is the difference? Lstat is identical to stat, except that if the path name is a symbolic link, then it returns information about the link itself and not the file. Right? Let me tell you an example. Right? See, now look at that. Okay, you have got a file called 0, right? Test, which I have created, test, right? Dot C. Assume that this is stored in the hard disk physically, guys. And this is the name which will point here. Okay. Now what I can do is I can give another name for this also. I'll give UPK. This also points to this. Now we call this as all symbolic links. When I delete this, file is not going to get deleted. It is still continuing until all the names are removed. Okay, it is there, and this is what we call as a link. And when you look into ls-l, it shows link. Look at this here, number of links, 3. Shall I increase it to one more? Okay, in order to have another name for the zero test.c, I use a system command called ln. And I don't know the syntax of the ln. What to do? Manual. Prefer manual, man, ln. It goes. ln makes link between the files, right? Now look at that ln options are there. Target link name, right? So options, right? Target and the link name. Target is what is the file name, original, and link name. That's the syntax. Look at that. Creates a link to target with the name link name. The second form creates a link to the target in current directory. Leave it. Right? Are you clear? What are the options? There are many options. Right? Interact to prompt whenever to remove the destinations. Okay, dereference target. Symbolic. Make a symbolic link instead of hard links. Minus S. So let's do that now. Ln minus S. I'll say, okay, UPK, right? 0. I'm sorry. This is the target is 0 test.c, then UPK algorithm. This is symbolic link, right? Created. Now let's look into that. ls minus l, right? 0 test.c, right? Thus, it is symbolic link. Hard link count is not increased, right? But when you see ls minus l, right? Okay, UPK. See, this UPK is a symbolic link. It refers to this. This how we did it. Symbolic link, and is shown here. L. Are you clear about this? It is a symbolic link, but hard links are different, right? Hard links are different. So now look at that. I want to create hard link. LN. I'll say UPK. Sorry. 0 test dot c UPK. File already exists. Alright. UPK1 already. Right? Now look at it. ls minus l 0 test.c. Physical count of the hard link has increased. Are you getting it? Right? Are you clear about this? Are you clear?
Yes, sir.
Okay. Now, to give a more clarity, okay, let me refer to one of my presentation slides. So what all the command we are used? ln we are used, lstat system call we are used, start, right? Plus ctime. Okay, please remember all the things, right? Operating system, presentation slides, okay, introduction to standard, okay, Unix files. Okay, let me take you to Unix files. When I talk about the file, we have different types of file: regular file, directory file, FIFO file, character device file, block device files, etc. Leave it, right? I was talking about the StartH I told you. Let's not get into this right now. Yeah, symbolic hard link and symbolic link I was talking. Symbolic link file contains a path name which reference another file in either local or remote file system. Right? Symbolic link may be created in Unix via ln command. ln minus s I told you. Okay. It is possible to create symbolic link to reference another symbolic link. Remove MECH commands will operate on symbolic link also. Right? I gave the same example. Cat 0test.c, get it file content. You create something, right? Cat this, it will refer the same thing. And you will get a symbolic link like this. I told you. Please refer this. And when you remove it, a simple example, I created, just a minute. So I created, okay, UPK1 is symbolic link. Now look at that, cat 0 test.c, you will get this content. The same thing you will get it with UPK1 symbolic link. It refers the same file, right? Now I'll remove, right, UPK1, right, file remove. Now again do that, okay, cat UPK1, yes, it doesn't exist. Symbolic doesn't exist. It doesn't read the physical file, right? Are you clear about this? Right. Now, what are the further differences between symbolic file and this? Let's have a look into that. Hard link is a Unix path name for a file. Generally, most of the Unix files will be having, right, these things, only one hard link. In order to create a hard link, we use a command that is ln. ln minus is create a soft link. Right? Symbolic link can be created by the same command with minus this option. Already you know. In command, the ln command differs from the cp command in that cp copy creates a duplicated copy of a file. Cp copy also it creates a duplicate, but ln doesn't do. It refers to the same thing. Right? Whereas ln command creates a new directory entry to reference a file. CP creates another file. This is the difference. What is the difference between CP and ln? CP creates physically the another things file. Whereas ln command creates a directory entry only. Content is same. Are you clear about that, Manoj?
Yes, sir.
Okay. Now look at that. Hard link. For hard link file, ln user so and so. This is the original and this is a new thing. Right now, what happens is the inode number. See here. Right, ABC 201, hard link I'm talking. Okay, then if you look at the XYZ, okay, that is also 201. It creates, right, okay, the link to that, that's all. No new file is created. Are you clear about this? Right? So this is about the, okay, ln. The content of the directory files, user name and user EPK. This you can see here. For same operation of elements is command, right? A new node will be created. Now look at that ABC201, right? And you have a XYZ, okay, 450. I know number will be different. The content of the directory files will be same, right? So look at that, okay, comparison on that. Hard link does not create a new inode. Okay, symbolic link creates a new inode. Got it? Then hard link, it increases the hard link count, whereas it does not increase the hard link count. It can't link directory files unless it is done by supervisor. It can link directory files also. It can't link a file across different file system, hard link, but across file system it can link. There may be several file system available, right? Yes. So these are the few the understanding of hard link and symbolic link, right? Remember, two important things. Hard link does not create a new inode, right? It increases the hard link count, but whereas it creates a new inode, does not change the hard link count. Right? Hard link and symbolic links, it helps to save the disk space over the cp command, copy command, but by not creating a duplicated copy of the files. And through any of the hard or soft link, if you change the content of the file, it will change everywhere. But this is not true in case of cp command because the separate file is being created. Are you clear about that? Shall I close this? Shall I close this?
Yes, sir.
So with this, okay, we have completed what is called as, right, displaying file attributes. Direct listing, yesterday we have done it. So now you people combine these two things and implement ls-l command. Is available, help is available in Google Class. All boys can interact with Manoj. Right, interact with Manoj and see that you do on your own. Right. Now what we'll do is, okay, we'll see the file operations little bit and fork in V4. Today at 11:30 class is there. 11:30 to 12, half an hour. Everyone must join, right? And Manoj will be engaging the sessions. I'll be there, right? Telling difference between fork and V4. And on the top of these programming things, right? Theoretical description. What are the? It's given in the question bank also. Question bank is known to you people. Question bank, sample question bank for this. Hmm. I did not post any sample question bank here for SE. Hello? Manoj? So sample question bank is here. It has come.
Yes, sir.
Okay, it has come here. Right. Question bank. See, all of you see here, right? All lateral entry student, you must prepare the answer for all these things. Explain the dual mode operation. Explain why dual mode operation is required for general purpose operating system. List and explain different services offered by operating system. Draw the state diagram and explain different state of a process. Describe the difference between symmetric and asymmetric multiprocessing. What are the advantages or disadvantages of multiprocessor systems? Right? Explain the Unix operating system layered architecture with a neat diagram. Explain the following command: echo, ls, who, date, pwd, type all these things. Right? Then list and explain different types of scheduler implemented in operating system. Long-term scheduler, medium-term scheduler, okay, short-term scheduler I discussed. Right? What is context switching? Explain how process control block is useful in context switching. Right? So prepare the answer for all these things. Lateral entry student. Right? Similarly, you need to, right? Write a C program to display the attribute of a file whose path name is passed as a command line argument. Describe the meaning, okay? Describe the meaning of 7 fields of ls command. I explained. Using appropriate system calls, write a C program to simulate ls command, which you are doing assignment, right? List and explain the system calls and libraries required to run a program Y from another program. exec command, I will explain in this week only. Right? So probably tomorrow morning I'll pick up this. Try to see program to implement a requirement mentioned in Q4, all right. Try to see program display attribute of file passed is command line, which we have done it. Try to see program to create a child process and explain difference between fork and V4. Today afternoon we are doing it. Yesterday also we did it lately bit. Explain the layered architecture of an operating system with respect to working of APIs, printf, scanf, with other corresponding system calls. Look into that. Right? This is about the unit 1 and 2 preparation that will guide you, okay, for better preparation for that. Right? So the session is closing now. Shall I close this? Shall I close? Hello, Manoj, Dhoni.
Yes.
Yes, sir.
Yes, sir.
Manoj, right, we will be back here at, okay, 11:30 sharp. And Manoj, quickly you will be covering fork and V-fork, the example, whatever I have given, same thing. Right, quickly. Right? So, shall I end the meeting now? End the meeting for all?
Yes, sir.
Okay, thank you. Right, bye.